All right, top of the hour. Let's get my camera set up. It's the 15th. We're flying. That's for sure. Lots and lots of stuff happening in this space. And I've been obsessed a little bit lately with the idea of the sort of edge-based stuff. This week has been just crazy. Like I'm going to show you some devices that Finn and I have been working on. This thing in particular, it's a Haltech device. I've got it on AliExpress. It's got an ESP32 style chip in it. Basically, this thing. So I'll show you what I did there. This thing can detect signs of life under rubble and create communication channels that can't be intercepted by sort of surveillance systems. All kinds of crazy there. I see Jed. You're back for the new year. How you been doing, Jed?
Just burning tokens at a rate that was previously impossible. So now I'm at the point where I've got three Max sessions in flight, plus another two GLM 47 sessions, building out at the moment a market making tool for Polymarket.
Nice. That sounds like Polymarket's been someone made a fortune on Venezuela. It was like a week ago. They basically like predicted within the matter of like an hour that he
The
was going to be.
Pentagon pizza tracker is all you need for anything to do with US's
Oh, we
forceful
correlate.
foreign policy.
Okay, so we correlate between Polymarket, social media, and sort of global events, and then you make your bid on Polymarket. Yeah, I like that. So V3 is out. I just published it like an hour ago, to latest. And thanks to everybody who sent, comments. Stu, you were amazing in the beta testing of RuVector. You found I don't know how many bugs. Thank you, everyone. I know it's crazy that I was able to get 12,000 downloads before I even announced it, but that really made it a lot easier to do the debugging. Windows support. I know everyone was like, why don't you support Windows? We do support Windows now. You can let this thing optimize your registry. You can like overclock. So if you're into hot rodding, this might be the best hot rodder you've ever seen for taking like an old shitty laptop and making it run like it's like brand new. Give that a spin. You see, it all runs locally. And I'll show you guys how to run all this stuff. But before I do, yeah, Stu, good to see you, and thanks again for all the work on RuVector. Like you said, you've been working on some new stuff.
Sorry, was that at me?
Yeah, Stuart. Yeah.
Yeah, yeah. I've been a bunch of new projects, everything that we can do with RuVector. I've got two different clients that want to use RuVector, RuVLLM to come in and do secure research on their own networks to be able to understand processes that their IT departments won't let them send off-site. So definitely looking forward to using that as a process. They're both $1 billion clients that are like, this is a huge problem. We can't bring in AI because our IT departments won't let us do it. What you're turning around is creating a solution that enables that to happen in a highly secure fashion. So it's a lot more interesting.
Yeah.
And I've got about 5 different projects going at all times. I finally got to the point of having to do Peacock on VS Code because I couldn't keep the darn projects straight. So I needed to colorize them so I could know what each one is. But
You know what I've been doing? I've been stacking Mac Mini Pros, and for bang for your buck, for sort of multitasking, which it sounds like you're doing a lot of the same sort of thing I'm doing. I'm
yep,
juggling many things, and the so as you can just get so much performance out of those things, and they're dirt cheap. So
yep.
I just stack them up. And then I use the RDF connections, and I can just sort of jump into them if I need a UI. But mostly I just use them command line and as part of my swarm, and it
That's
forms
great.
the local swarm, if you will, and everything permeates from that.
Does it matter which model you buy?
Yes, it does. Actually the best if you're looking for a really good value, slightly older model, you look at the M3 Pros from like about a year and a half, 2 years ago. They're the way that they did SIMD and the ability to interact directly with the sort of core CPU structure is the best. Now, if you like the more new stuff like the Neuro and the GPU optimizations, then you're getting an M4, but they're more expensive. I First, if you want to spend $1,000, get the M3 or less. You can sometimes get them for like $500, and you can
How
stack
much
this. back them up.
That's great.
How big
Are
are the
you
models that
cluster-
you're running on it?
Thank you.
What's that?
How big are the models that you're running
Tiny.
on it?
I'm running Root Vector. I'm running tiny little models of them, tons of them. I've completely gone away from monoliths. I don't bother with them. I don't need them. I can do everything I need with just a whole collection of very tightly learned and structured language models that are like in the 2 billion sort of range. They reason, but then I can just fine tune them specifically for what I need them for and tie them together for different purposes. And that's all I need.
So are you at the point where your Claude code is independent of Claude Max?
Yeah, I easily. Yeah. So for that, I'm using generally right now, the best model I use for that is I like Qwen or DeepSeek. They're kind of similar. Like DeepSeek is kind of a like a modded version of Qwen. So if you want to sort of do it yourself, the Qwen models are all great. And those are my go-to for doing it myself. And then I can just replace that using the in the system called Agentic. And I'll show you guys this in a minute, but you can replace the core of these systems and mix and match the different models. So in the structure, actually, I'm just going to jump in and show you guys. I'm excited. So here we go. So in the structure of the system, we've got the core concept is this learning loop, right? You're doing something and the system gets better in the most basic terms. Now I can replace and I can orchestrate how and where different agents and requests are made. I'm using the core of Claude Code as a kind of SDK. And once I looked at the sort of the inner workings of how Claude Code worked, I can then tie directly into features that they don't necessarily expose or want you to use directly. So in some of those things were like, I can then dynamically change which model an agent uses based on this idea of cost versus performance. So for a lot of things, I don't need it to use Opus 4. I only needed to use Haiku or whatever. And when I switch to Haiku, I get like 10x more usage, right? And then I can switch to Sonnet when I need sort of a kind of implement this code area, like I need you to just do sort of busy work. Or if I need it to really think hard about something, then I can switch it back to Opus 4.5. That entire process improves the overall sort of usage of the system by like 250%. So I'm using way less capacity on Claude or the different models I'm attaching it to. If I want to use Gemini, I can now say, for this task, use Gemini or use ChatGPT or OpenAI or whatever, and I can allocate that dynamically. So that.
So can I ask a question then?
Sure.
Today you're switching between models within Claude for the progression of Claude Code, but you've also talked about using local hardware. So where would you choose to use local hardware versus still continue to use Claude?
Well, so let me show you that quickly. Oh, well, let's go here. So this is running in my Windows system. So you can see here it's running Cloudflow V3. Now I'm getting it to program these devices, right? These are physical devices, and I'm able to now.
Yeah,
Yeah.
what are you showing here?
We're seeing Vibecast. We're not seeing anything else.
Oh, sorry, I'm sharing the wrong screen. One sec. There you go, guys. Sorry about that. All right, right screen. All right, so this is my Windows console. So you can see here I've got Cloudflow V3 running right at the bottom. So this is managing the implementation of the WASMs and various Rust components on physical hardware. Like this is a device that I'm using. Now in this case, because I'm able to interact with Claude both locally and through the peripherals on my machine, I can program against kind of the physical world in a sense. So this is a perfect example, and you're not going to be able to see it too well here. But basically, what this is a device that has a radio system, some sensors, and the ESP32 chip in it, right? This little silver thing here. And what this is doing is it's using the ability to use the micro sort of decompose and CSI to one set up a network using multiple machines like this Raspberry Pi Jobby with a screen on it that I can use as a kind of like radar, if you will. And what this does is allows you to see through wreckage and find signs of life. because this is detecting the permutations in Wi-Fi, slight alterations in the path of the returning packet through the Wi-Fi network, it measures the sort of jitter within that. And what it can see is it can make the distinction of different things, like concrete versus a human body or water. It can also measure those things, so it sees like what's happening within that. So every time I breathe, it could pick that up. But it does that on a 1 hertz basis. And I think, Jed, did you do the math on 1 hertz? What or 0.1 hertz is?
One
Some
tenth of a hertz, so one every 10 seconds.
one every 10 seconds, right? So we can pick up the very slight movements in things like your pulse, heartbeat. This can detect the heartbeat signature of anyone in proximity to it. Now we can do that again for people who are barely breathing or barely alive. For example, 1 breath a minute or 6 heartbeats in a minute. And then it can triage and say, of those people, who are the ones that are, one, most accessible, two, are likely not going to die, and three, the path of shortest resistance to get to that spot through rubble or an avalanche or whatever on a 20
So-
freaking dollar device.
So the way this works is it's basically detecting the saltwater content around it the same way an infrared camera measures heat.
No, it's detecting movement, not it's detecting slight
What is it
permeation.
reflecting off of?
It's reflecting it's the path that the Wi-Fi signal is taking to and from the Wi-Fi transmitter, and the
Right.
slight
Wi-Fi
permutations in that path.
The 2.4 gigahertz spectrum is affected by water, especially salt water. So I'm curious to know how it penetrates snow in an avalanche
I
situation.
can go anywhere from 40 megahertz all the way up to I think 5 gigahertz on this. So I can choose and play with different RF signals and find the optimal signal to get to find its way through different forms of material. The system, which is using RuVector on directly on this, is always learning and following the patterns. So you can't really see it, but basically there's a structure here that I can change the different settings. This is a button, and I can see what's happening, and basically it's looking and learning at the different signatures and structures, saving that to a hyperbolic vector space. Oh, by the way, I got to show you guys something. I mapped what the AI looks like and animated it, and it's bananas. All right, here, I got to show you guys this. I hopefully I share my right screen this time. If I don't, tell me. All right, so I'm like, this idea of a hyperbolic structure is really interesting, right? It's a rather than a plane, it's a circular sort of spot with that goes on forever in a sort of spherical pattern. Now, in my system, I'm using this idea of latent space. So you can think of latent space as a space outside of this animation right here. And then within that, we've got the ability to cluster using vectors. You see these brighter dots that look like planets? Those are more collective sources of learned information, and you can see that some are bigger and some are others. The sort of dots floating around it, this is the sort of GNN that basically thinks about how and where and why and how to find your way back to the most important bits of information. You can think of that a little bit like a synapse, or in a combination of synapse and neuron. The larger neurons have more information, the smaller ones have less. Now, within that, I've defined a hyperbolic graph structure. The hyperbolic graph structure is, and this looks amazing, I might add, is based on this kind of structure. It's almost like a flower, and it's beautiful, and for at least to me. And then the outer structure here, you see this kind of rotating line structure. That's the graph. So within the structure of this, we've got a graph that represents its reality. That reality interconnects to all the various forms of information available to it, both vector, latent, and kind of implemented structure. What's connected and how is it connected and what does it mean? But it's pretty cool, right? Like, this is it. This is how the structure works and visualized. And I took this and I made a WASM, of course I did, which is basically the actual mind and structure. That this is live system as it operates, and I'm visualizing it as an output in animation using Three.js, I think it was. Yeah, and I'll publish that.
Ruth, can you show what the chip looks like? You have the package on the desk.
Oh, so yeah, this is the ESP32, just to be clear. So the ESP32 is 3 centimeters, I think, size wise. It's slightly less than an inch, I guess, or maybe no, slightly more than an inch. And then I can put those into different devices. So mine will be, when it comes out, mine will be 256 of these. Right, this is one core running at 240 megahertz. Mine is 256 cores in the same spot running it up to 400 or 4 gigahertz that I can control independently of one another all at once using a spiking neural network and doing.
Hey, Rue, when you're showing us that, just pull it back a little bit.
Blurry?
Your webcam isn't focusing. Yeah, that's better.
So
All
is
right.
that the S3, the C3, or the P4 variant
This
of
is
the
the
ESP32?
this is the S3. This is I like the S3. It's good, and I've got a thermal optimizer on it, so I'm actually optimizing the amount of energy that's being used in real time. So that allows me to basically reduce the energy consumption on the battery by something like 85%. So this, for example, goes from running on a sort of watch style battery, which would normally last about 3 weeks. I according to the calculations that I got from the AI, so take it with a grain of salt, that this thing will last 5 years, right? Some much longer period of time. So, and that's is optimizing the flow of the atomic structure that I can then, and this is, let me just show you this. I'm going off into a deep end for a moment, but you guys can entertain me. All right, so I'm gonna log in here, and this is a real simulation of the atomic structure of the actual atoms that flow in these chips. I can't do it to that degree on the ESP230 on the 32 because I'm not the manufacturer, but on mine, I can actually get to a point where I can simulate the actual flow. So now if I want to go to semiconductor and I want to define the structure of the flow, I can choose some options here. All right, I'm going to zoom in here. So this is the atomic structure of the actual chip. Now I'm going to adjust the temperature slightly. I'm going to change my force field a little bit. And let's see what other presets I got here. I'm going to choose Intel just came out with a brand new chip architecture. It's a 1.8 nanometer. So we're going to use that. So then I can simulate that. You see it changed slightly. And then I'm going to set it to learn. And I'm going to play. So now what's happening right now is I'm simulating the atomic structure of the flow of atoms within this particular chip. And now keep in mind the chip within the 1.8 nanometer is actually 5 freaking atoms across. So what I'm trying to do here is learn the structure to sort of optimize the flow of these atoms, both in terms of compute performance and energy, which is like you're now working with the fundamental elements of the universe in some weird way. So what's happening is this is simulating it. So I can then adjust the settings. I can change how the temperature is. So I'm going to turn the temperature down to absolute 0. And at absolute 0, you can see nothing moves, right? So now at absolute 0, I can then play with other components. I can change the time steps, the determinism, and so on. I can change the structure altogether. So I can choose here, for example, let's go with molecular dynamics. So this allows me to define, let's set temperature low again as well. Different atom counts. And this is learning the entire time. The system's using that AI that I was showing you earlier. It's updating the latent space and creating a world model. It's providing the ability to understand the interconnected relationship of things and structure and matter, and then simulate that within that structure. And I can get down to an atomic level. So when I'm creating a world in this particular environment, I'm starting at like this kind of subatomic level and then building simulations at each part of that, each level. And and what's interesting about this is I can run these simulations for all kinds of different purposes. So if I want to run this for like a multi-agent swarm, this is a multi-agent swarm, for example, and I can change my observable radius. I can say I want less and goals, and each has a different look, right? Here's let's see what else we got here. Quantum. So this is a quantum structure. So then I can play with the quantum structure. I can change. I'm going to change that to lower. And you notice at the quantum level, even absolute zero, it doesn't stop the structure, right? And that's the interesting about quantum mechanics. But it's beautiful too. Like, look at this. And then I can go to my presets. I can choose a quantum well or quantum dot array. Lots of different little settings there. I can change my learning structure. Now, depending on what I want to do, I can look at my neural fabric. I can define like, hey, look, this is different attention mechanisms and how I want those to work, and the importance of head. So it's learning on all these different structures in real time. Everything I'm showing you right now, well, that's all in Claude Flow V3. So I just gave it a UI. But this is essentially what Claude Flow V3 is built on. So it's built on this concept that you can actually go in here and you can describe, Claude Flow as a kind of smart orchestrator. And they've done a really good job of creating an orchestrator that's broadly used. Like, one of the big things I'm seeing right now are gigantic companies coming and saying, we're going to replace all our coding tools with Claude Code. I've had that conversation no less than 4 times just this week, and we're talking companies that are many billions in terms of size. Claude Code is legitimately taking off, and I think the 400,000. If you look at my downloads, 434,000. When you look at who's getting that, these are large enterprises. These are multinational organizations and everyone in between. And we're seeing this kind of hard takeoff of capability. And so I knew that I learned a lot from Claude V2 and V1, but I knew I needed to re-architect this whole damn system. So for those that are interested, I created a comment here. Well, anyway, this will be a post I have coming out later this afternoon when I more formally announce it. Oh, it's not loading for some reason. So basically, you've got a variety of different core components, and I made it modular. So the most important part here before we start is you can run it this way. Just run, in it, and you can win it. I created a plugin system for it. But let's go through the core capabilities. So again, it's backwards compatible. So if you have an old version, it should just work. I haven't had any complaints yet, and so it looks like it is just working. Swarm coordination. So I've got one of the big changes you're going to see in the swarm coordination is the hierarchical mesh. And that is now part of the Claude Code MD. I'm not sure if I'm using my output one here, but we'll take a look here quick.
You had a question there, Tom?
Yeah,
go
I
ahead.
did. I just was wondering, sorry if you already touched on it, but
Okay.
if you had already tried out the Claude Cowork, and a lot of feedback I heard about it was just pretty much taking Claude Flow and putting a nice UI on it. But I wondered if you'd played with that at all, and what you thought about the UI. And then the second thing is, if Nick gets a chance to respond to my DM, I had a line on an event space for. I know there was some trouble with it for January, so I had a line on that. So I pinged Nick. So that's a separate line, but he hadn't got back to me. Oh, I see he's responding to me now. But back to the code workflow. What your thoughts are on that?
I'm going to hold my thoughts for now. I think. Yeah, I've had a long relationship, a long, not great relationship with those guys. I think they just need a little attribution, like, I thought.
Yeah, if you're saying
we'll,
that some of the stuff looks like it might have been lifted from your earlier work,
well,
it definitely looked that way to me, even when Claude Flow came out.
It's a repeating pattern, like the agents, for example. They were a little blatant in just taking my nomenclature and structure. Like, if you're going to do that, like, put in a comment, or like, I give away all my stuff, and I want that stuff to exist in the real world for real people to use and do really cool things with. And I give it away under an MIT license, which means it's pervasive. You can basically build your own company around it. I want this to exist for people. But
well, I thought that maybe you should consider switching to GNU, because at least that forces attribution. Like, they have to at least cite you about it,
No,
enforcement is the trouble, Tom, and it's not worth the operational burden.
Oh, yeah. Okay.
GNU is wrong. My code is being summoned, if you will, conjured from AI. I'm a conduit, and I sound like a nut saying it, but I'm a conduit to create this stuff and make it, put it out there. So, if people are asking the same questions and coming up with the same ideas, they'll likely be able to conjure similar things. So I'm bringing those things and making those things real, and is where, as far as real can be in software. And I think that I'm not saying that they have to give attribution. I'm saying from the point of view of inspiration, sometimes it's a matter of saying where and how you got that inspiration. And when I'm building this stuff, I do show and include attribution to libraries and materials I used and borrowed and to create really interesting things. I just wish they would do the same thing.
Yeah, it's pretty surprising because on balance for a lot of things, especially things like safety, they're pretty transparent, but it does look to me, I mean, it looked pretty obvious to me too that some of the stuff was lifted from your work and
Yeah,
not
it's
liking it.
okay. It's okay. I'm not hurting it either. So it's all good. So
You do realize it's a fully philosophical question of when you write something or develop something with an AI, should it be released on an MIT or a GNU license?
yeah, that's what I'm saying. It should be MIT. All my stuff's MIT. I've got,
Well, you're actually a little bit
GNU,
incorrect. You're a little bit
GNU.
incorrect.
I don't want to have a license debate here, guys, but GNU, in my opinion, is for the wrong reasons.
Yeah,
Like
with that I
it's
agree. With that I
but
agree.
that's a conversation for
Yeah.
I think maybe another time. All right, so I'm just gonna jump back in here for a sec. So just to get back on track here. All right, so what I did here is I created a little graph. Maybe this will help you. So, and how I sort of compare what I'm doing, and a lot of the stuff, to your guys' point, is pretty out there. So, first of all, self-learning. So I've got this self-learning architecture. I'm not going to get into it today. It learns, it adapts, it gets better. The EWC allows it to never forget. So learning is important, but understanding and remembering is just as important. So the system prevents forgetting. The routing. So I'm using this concept of kind of mixture of experts. Now, the way that I use experts is totally different than the way most language models use experts. I'm using experts as a mechanism to define both sort of informational structure, and these could be things like graph and vectors and sort of the structure of the information itself. But I'm also using it from the form of the language model by doing micro fine tuning of tiny little models, little brains, if you will, that are optimized to do just one thing and do that one thing really, really well. Right. So it doesn't have to be smart for everything, but it needs to be smart for that thing. So it needs to be smart for detecting cancer or listening to my heartbeat, finding people buried in the snow, whatever it happens to be, and be really smart at describing that in a way that's useful for other things. That could be a
What's
map.
the upper limit for a single brain's capacity?
None that I found.
So I
I'm
imagine
using,
it's bounded by parameters, for example, or memory. I don't
yeah,
know if you've found those
I
kinds of
haven't
limits.
I haven't found any limits, but keep in mind, I'm using the 500 million parameter model from like Qwen, right? It's 64 megabytes. So I'm using tiny little models, and then I'm incrementally training them step by step using the simulation that I showed you earlier to get better and better and better at things. And then that acts as a kind of initial pre-training. So I'll train models for particular use cases, medical or financial or whatever. And then that provides a kind of kind of the instinct of the model, right? It's like an evolution. The bird knows how to fly south, right? But it also learns where food is in an incremental stage when it went to a farm and saw that it could come back and get food again. Different forms of learning. I'm
So are
using
all of
both.
these models deployed on a mixture of experts basis, or are they all completely independent and just hosted in the same memory space?
The system uses part of RuVector called Tiny Dancer, which again I was inspired by when listening to the song or whatever. But that basically it creates a GRNN that auto directs to the appropriate expert by learning the structure between the information, where it needs to go, and it can do that really, really fast, sub-milliseconds sort of time frame, and that allocates different models. Then those models could be embedding models. Those could be vector style models. They could be language models. They could be various ML models, attention mechanisms, and other things that provide information. It could just be a straight up SQL database. That handles the sort of allocation and request component. Now, the next part is the HNSW algorithm that allows me to traverse that complex network and graph structure in really, really low amount of time. But to optimize that, back to that animation I was showing you guys earlier, I'm not using a Euclidean structure for the vector, the information, which is normally a sort of plateau or plane or piece of paper kind of thing, sheet, if you will. I'm using a spherical hyperbolic structure that expands forever from a center point. That greatly improves the recall capability and the ability to iteratively learn and update the vectors in themselves. So rather than having to do a complete and total sort of re-indexing of my vector every time, I can incrementally just change the particular parts of the storage of that information that needs to change rather than having to do everything all at once, which was the biggest drawback to sort of RAG-based approaches. If I got a lot of information, I'd have to frequently re-index it, which was heavy and computationally took a long time. Now I'm doing it iteratively as you learn. The next is pattern learning. So this is from trajectories. So when you think of trajectories, you can think of the nervous system, the structure between where you touch something and where that goes in your brain and the path it takes to get there. I'm defining these trajectories that allow you to learn the optimal path to get back to where the most probable, or in the case of a deterministic system, the absolute thing it needs to know. And that's always training and learning and optimizing as well.
So
Then
is all of this running in your Mac Mini cluster?
no, this is all running. Well, this could hypothetically all be running this is running on the WASM embedded in the Claude Flow V3 system. So under the hood, if you look more closely at what I'm doing, I've compiled all the various parts of RuVector into WASMs. These WASMs I placed in the structure of the Claude Flow V3, and it can use the local compute resources that are available to it within wherever Claude Flow happens to be running. So if you're
all
running,
of this is still running in a code space somewhere?
oh no, it can run in Windows, like I was showing you earlier. If you're running in Windows, for example, rather than a code space, it would see that you've got optimal SIMD. You might have AVX5.1 that optimizes for core processing. It can also spot that you might have other optimizations that it could take advantage of, and it detects those things and optimizes for it. And you now sort of I don't want to call it a virus because that sounds terrible. It's this thing that spreads and improves whatever it's nearby. Not a virus.
So it's a benign parasite almost. It improves the host.
It's a symbiotic relationship for sure. It sort of spreads its tentacles into the system and optimizes for it. I don't know what you want to call that, but that's what it does. Work ownership. So there's a claim system. So now you have multiple levels of workers. So you've got background workers using RuVector that sit in and operate independently of any language model, Claude Code, Claude Flow, Claude, whatever language. It operates without a network. So this thing doesn't need to be connected to the network. It'll just operate. Now, once you've got that in place, it's always looking for things on different incremental basis. So I created an always running daemon that basically will say, is it still secure? Are you running against your correct benchmark? Is there any drift in what's been developed? And it checks all those things and incrementally updates the status line. So when you go into the system, you can see here that I've got a status line, and the status line at the bottom is basically saying, are all my domains correct? Yeah, I'm done. Is my architecture still on point? 98%. There's probably some tests or something I need to fix. Am I secure? Yep, all tests are passing. It checks those tests frequently and checks that no vulnerabilities have been injected into your code, which is a common issue, right? You get something secure, you go and you create something new, and you're like, it's still secure. No, it isn't. This will find it and will tell you that it's not secure. Moreover, you could get this thing to basically just automatically secure it if it finds that. So this is giving you a kind of view. This is telling you how much it's learned. So this is basically a 28% improvement in its ability to do certain tasks like write files and code and various things. So it's using that vector structure to essentially learn. Yeah, it's doing all that. All right, so needless to say, none of these systems do the threat detection. I've got attention optimization, and I've got several different forms of attention that can be applied depending on the problem in which you're trying to solve. So if you're doing research, for example, you're going to use a different attention mechanism, so the system can go and understand why and what it's looking at. One of the more interesting parts behind the scenes, I should also note, is the system is using this idea of min cut. So when it looks at these graphs and looks at the various sort of graph structures, it's essentially trying to find and discover the things that are about to break. And it turned out the big sort of aha moment for me when looking at these autonomous large systems, deploying millions of agents, was not what it needed to do, which was important, but how it was going to sort of break, and then looking at everything it wasn't doing and using that as inference for what it should be doing or how to modify what it was doing. So it's like the anti-pattern. And it turned out there was more information in the anti-pattern than there was in the actual, like, go do this thing and tell me if you're doing it right pattern. And as soon as I sort of discovered that, the system started working quite a bit better. And that is a algorithm that came out about a month ago, dynamic min cut, but that cuts most of the structure, and it works amazingly well. Yeah, low rank adaption. This is the micro LoRa structure. It quantizes. I'm using 8-bit. I've been thinking about moving to a 7 integer, and I think I'm done with round numbers. And I think that when I was looking at sort of quantization, I kind of quickly realized that when I quantize with 5, 7, 3, I could get much better sort of deterministic structure, because I could then correlate that to a known pattern. The known pattern is actually pi. So I use pi as the constant in the structure. And it turned out the combination of a kind of odd or even a prime number in parallel to a known constant that goes on pretty much well, I guess it goes on forever, it's pi, worked actually really well together. And so I'm going to probably update that in the next few weeks to that, but that's a little out there, so I'm not quite there yet. But if you are into that sort of thing, it's actually in RuVector today. You can go ask Claude about that. Yeah, let me pause for a moment. We should build something, by the way. But we're gonna build something crazy.
We should. Roof, just a bunch of us are going to have questions.
Oops, you lost you for a sec, Stu.
Sorry, Roof. A bunch of us are going to have questions because folks don't know what to implement if they're going from Cloudflow V2 to Cloudflow V3, or if they already have RuVector there. So there's some of the chat's been about, what do I install? What comes with it? Do I have to uninstall other things?
Yep, and we're gonna do that right now. I'm gonna set up a project, and this is the part that you're gonna follow, and you can basically do this, do this along with me if you like. So we're gonna go through the entire process.
I have a quick question, Rube.
Yeah.
Of the enterprises you see, of the enterprises that are adopting, are you starting to get a clear indication of how they're using one developer having 10 agents and how they're working together in the enterprise?
The number. So first thing, these agents aren't people. They're not replacing people. There's no correlation that I can see between agent and people. This idea that somehow this agent it represents a human head count, maybe on the aggregate, yes, it does, but the actual implementation of an agent is not and should not have any direct sort of like correlation to how a person works, because it doesn't work. All the things I'm showing you guys right now, it thinks a little bit like a person, but that's about it. So when you need to look at this as small bounded tasks, things that are, the more narrow, the better, the more operationally, repeatable, the better. And that's, a combination of learning, recursion, logic, comprehension, reasoning, feedbacking on itself all the time. So to your real question is, how bad does this look for coders in the market? And it looks real bad for people who answered my "do you still code with raw code" question on LinkedIn yesterday, that answered yes, I do 90% plus of my code by hand. They're doomed, 100% doomed. The people at the bottom that were saying I use a bit of it, or some people commented I needed somewhere between 0 and 10%, they're the new norm. And what we're going to see what I am seeing are people who are adopting my technology capable of building the most amazing things in a moment. And these moments when I mean a moment, I'm not talking weeks. I'm talking like we built this in an afternoon and we ported our entire legacy system from COBOL to Rust, and it just worked. And that took us an afternoon. And one company told me they had a quote for $50 million to do that, and they did it in an afternoon. So big four, you're big fucked, which probably isn't the worst thing in the world. And the nature of being able to create
At some
is
point, can
changing.
you take us through that?
Yeah,
Yeah, that's amazing.
let's do it. All right, I'm going to show you. I'm
Because a lot of us are going to be interested in understanding how you do the convert
Monty,
something old
question?
into new, what it looks like, how it reads.
Sure. So what I had a concept here to do basically I want to early in the conversation we talked about the ability to sort of understand the voice and communication patterns of birds and whales and different animals. There's been some breakthroughs in this technology recently, and this bioacoustic signatures into navigational geometric space. Something that's crazy, complicated, and extremely useful. This acts as a natural signal that we can, or sensor almost, that we could use and implement and discover all kinds of things. So I got it to do a RuVector implementation of this as a quick deep research. I read through it, looks pretty good. I asked some questions. I asked it to make some changes. Can I use this to communicate with birds? I'm like, what's it doing? No, but you can actually use it to detect and model acoustic patterns, which is what I actually want. And you can use it to sort of as a kind of signal, if you will, on things like earthquakes or environmental changes. And can I use this? And I asked how to use it from practical to exotic. So it says we can use it for practical deployment now. We can use it for various forms of species and presence, automated species call type indexing. Basically, I can use it as a kind of way to measure things in the environment that we might not be able to pick up on. Now we've got all these self-learning capabilities that I can apply with it. That basically looks at everything it isn't and says, what can I discover? Toxic, exotic, synthetic bioacoustic dialects, and all kinds of crazy. All right, so we got that. So then I'm sharing this because I want a big shift. And I found I did some more research. I found Perch 2 came out this morning. Good timing. Perch 2 is a new embedding model specifically to help coordinate essentially this type of bird talk, if you will. So it was perfect. So RIB is the right framework for interpretation, and it's telling me some various differences about Birch 2. It's explicitly designed to reproduce beddings that stay useful under domain shift and support workflows like nearest neighbor, clustering, linear probes, and blah, blah, blah. So it's doing exactly what I want. All right, so now I've got this spec. It's not the craziest spec, but I didn't want it to be crazy. Now what I'm going to do here is I'm going to grab it. I'm going to go into the gist. All right, and we're going to go here. And we're going to go, and I'm just going to paste that in here for you guys. And we'll call it was bioacoustic. Is that what we were calling that? Embedding. All right. I think let's just check my Claude code. I think I actually did some research on this already. So let's just see what that looks like. Why is that telling me to connect? I might be in the wrong user. One sec, guys. I've got multiple Claude users. Yeah, I'm in the wrong user. All right. Yeah, you guys will have to deal with me for a sec. Now, maybe I don't need multiple users if my optimizer works correctly. So let's go back to Claude Code. Give a sec to its thing. Explore upper banks for hyperware search. Yeah, I did that. I created something else earlier. This is a new hyperbolic structure that I'm thinking I might be using. So let's go grab that for a moment. And we're gonna go, and I've got a Videcast instance I'm gonna start. So just wait for that, and I'll show, and I'm gonna install that, and we're gonna install Claude Flow. I got too much stuff open. Uh, All right, one sec, guys. I need to be a little more organized today. So I'm everything I do, I'm gonna publish as well for you guys, but I'm gonna do the install here. Connect to. I need hey, while I'm getting set up, if you got any questions, let me know.
Whilst you do that, Roop, just a general question for the group. I mean, what is a feasible? Two questions basically. First one is Claude Flow going to be always linked to Claude Code, or can there be possibility of a bridge between, say, let's say, where Claude Code generally is installed, which is Claude Flow, where it generally is, which is Claude Code, and let's say Google's anti-gravity system. Is a
Yeah, you can use it. I've got tons of people using anti-gravity. Yeah, a lot of people. A lot of people use it in. You know, you can use it right in Claude Code, like not Claude Code, but the you know, anything that supports MCP. It's an MCP, so it doesn't need Claude Code. It doesn't need Claude. It can run anything, local, remote, whatever, any model, anywhere, browser, chip.
Okay.
Yeah, I just do Claude. You know, this is called Claude Flow. I don't know, but it doesn't need it. You can use Agentic Flow and as well for that. All right. So and can you guys mute yourself when you're done? Just like you're talking or tapping or something. All right.
Okay.
Okay. So
And
first thing
Rube, a few of us are.
oh, I need to refresh this. Just having some. So was that a question, Stu?
Yeah, sorry. I'm just my AI note taker has been requesting access for the last 20 minutes to read AI.
Not sure. All right, MPX Claude dash flow at alpha, and I'm gonna do init dash force. Don't need to force probably, but I'm gonna do it anyway. All right. This it's not loading for some reason. I'm gonna see if I can connect on VS Code. Let's see here. It doesn't like screen sharing.
Do we do it init force even if it's an existing Claude Flow?
There's a migration system also that will migrate all your old stuff to the new structure. And
I
can
don't
show
need
you
to force for and don't need to init for.
well, the force. If I were you, I'd make a backup of if you've made modifications to your .claude folder or .claude, I'd make a backup, which if you're using, you know, you probably would have anyway. If you're using Git. All right, I don't know what's going on with the web version, so I'm gonna go here and give it a spin, see if I can get it working. The demo gods, right? All right, let's see. Hopefully it works better here. All right, so this time I do it again. Claude dash flow. Oops, I got it right. It's a bit of a delay here. I'm not sure what's going on. Flow at alpha init force.
Ruth, is it alpha or V3 alpha? I was seeing V3 alpha for a while.
Both will work. I'm actually just testing that alpha works. So
yeah, so you basically
They're both going to
so alpha is fine.
They're both going to alpha 118.
Yeah. Okay. Good. I'm not gonna do it here. I'm gonna do it over there, and then I'm gonna go back here, and I'm gonna create this. We're gonna call this tracking the right shift. All right, and then there we go. And then I'm gonna grab this. I'm gonna go back to my original spec. I'm gonna pop that in here, and we'll go here. I'm gonna add. This is sort of introduces what we're doing, gives us some additional context. Then I'm gonna add this here, and we're going to give it a name. What should we call this thing? This is basically a mechanism to use, you know, life as a sensor. You know, birds, whales, whatever. It needs a clever name, I think.
Ambient life.
Ambient life, nice. Why isn't it copying?
The seventh sense.
Oh, I didn't get enough of it. The seventh sense. Sense, sense 7. Here we go. I'm copying the wrong damn thing.
Yeah,
All right.
Sense 7 is better.
Pulse sense.
Let's grab that. I need to grab. I'm just grabbing my data quickly. All right, so we're gonna pop that in here. Oops, I'm not using this one. I'm gonna close that so I don't get confused. And okay. So I'm gonna create some plans, new file. Oops, yes, I gotta actually say yes on this. All right, and then we're gonna create a new folder. We'll call it plans. And then we're gonna create a new folder called research. And new file. Research. Oh yeah, spell it right. Research.md. And we'll pop that in here. Actually, this is txt. txt. All right. And then we're going to go back here and we're going to grab this.
Why is it a TXT not an MD?
There's a text file. I like to, I'm, you know, my OCD or whatever. New file. This is the intro.md. All right, so we can take a look at that. That looks good. All right, this is the basis for what I want to implement. All right, so we'll give this a sec to install. I might switch these packages. Nothing seems major here. I like these packages, and it really doesn't matter. It's supported. I could probably recreate them if I really wanted to, which I might do. And maybe that's another project I could get going in the background. But for now, they all work great. There's no security issues. The first time you install it is the longest. You're downloading some embedding models and a bunch of stuff. But the subsequent times you install it, it will be much faster because it only really installs the things that have changed. So if you were using an older version, like an older Alpha 3 version, and upgraded to each Alpha, this wouldn't have taken several minutes. It would have taken like seconds.
How do you know that there are no security issues?
There's a security system built in. It's my AI defense system. Yeah, and that's what I was showing you earlier. The system will automatically monitor and sort of mitigate various forms of security exploitation. It's got a 3-step CSV process that runs all the time while it's running.
Okay.
I'm not sure why it's taking so long, but I guess I should have got this going a little earlier.
Ruth, what would be really nice is if you had an extension for VS Code so that you could use other panels in VS Code to relay statuses and stuff.
Yeah, do it. I'll create a PR, and I'll definitely put it in. That's a good idea. That's it. I don't need it. I only build this for me.
Sure.
Right. But if you need it, build it for sure. Okay.
I'm hoping someone will build it because
you can totally build it. Just create an issue in the Claude Code repo with a detailed specification following what I'm about to show you, and I'll just point the swarm at it, and it'll build it. All right. So now what I'm going to do is I'm going to go back and I'm going to install Claude Code. So I guess I should have probably done that. So I'm going to go back here to Claude. And we're going to go back to, where did I put that? Right here. And we're going to scroll down to the install. Where did I put that? Claude Code. And here we go. So I'm going to install Anthropic. And we'll do that. And Anthropic should install much more quickly. There we go. And then I'm going to run Claude. All right, we're gonna install that. I got a subscription. I switched accounts, so we're gonna open that. I'm gonna do that in my other screen. You guys get the general idea. All right, now we're installed. We're in. All right, now we're gonna do recommended settings. We're gonna do you try? Yes, I trust it. Now what we're gonna do is we're just gonna check Claude help. All right, now we've got allow dangerously skip permissions. I'm gonna grab that. Claude, dangerously skip permissions. All right. Now, Yep, they're good. Yes, we're good. All right, we should be in here momentarily. And Claude folder has lots and lots of new stuff it probably needs to digest. All right, first time, and then we're good. Oh, I've used 95% of my weekly. That's not a good sign. Maybe I should log in my other account. Sorry guys, logging out.
What about trying in anti-gravity for a change?
We'll do that next week.
Okay.
So then we're gonna go here. This isn't anti-gravity flow, just to be clear. It's Claude Flow. I'm sorry guys, I gotta log out. I'm gonna just do that for a sec. Claude, I'm in my other screen. You're watching me real-time debug. Well, maybe you'll run into certain. No, it's not really debugging so much as just making sure I log in the right place. All right, one more go. And this I'm going to log in again with my other account. Now, I probably wouldn't. I've got a system that optimizes, but I also want to run a pretty heavy duty swarm. I don't want to run out of capacity, so it's better to do it. All right. Now what we're going to do. All right, I'm just going to edit one more time. I should have probably installed it first. There we go.
Does it matter doing Flow first versus Claude?
Well, you know what happened? Yeah, apparently it does. And that was just a discovery. So what you noticed happened was I did Anthropic after I did Cloudflow because I was curious more than anything. And my assumption was right. It overwrote my status line. So you have to install Cloudflow after installing Claude Code, or you won't get my status line. But now you can tell it's working because I've got a status line, right? So we can see here the information. So we're in good shape now. Let's do a quick test. Tell me about Claude Flow and its development capabilities and the ADR DDD. Be brief. All right. Now you'll also see here there's a ClaudMD file. You can customize this as you want. My ClaudMD files are heavy, but I make up for the heaviness of the ClaudMD file by optimizing the routing for different models and not routing to the system itself. So this is heavy, but it doesn't really matter. I make up for it in other ways because I got 75% reduction in the amount of usage kind of thing. Anti-drift capabilities. This is telling it how to use the anti-drift. And this is preferred, so it knows that it should always use different structures. Hierarchical mesh is my go-to. The hierarchical mesh is my preferred. Use this, right? Use this where possible. That's what I'm gonna put. I'm gonna put that. All right, and you can customize this as you want, but just to give you an idea of all the things it does. Here's the Swarm protocols. All right, so that's looking pretty good. Now we're going to do a quick read through here. Now, one of the reasons I was just curious, you're going to ask the system how to use the system. Remember that. It's meant to be sort of, you're supposed to inquire, you're supposed to ask questions, you're supposed to, do sort of insight into what how it needs to work. So the reason I asked it about these two things is this is the core structure of how I create the PDRs and make sure it stays on point. So then we can let's review and we're going to go back here. We're going to tell it to review the research and create a detailed ADR DDD implementation using all the various capabilities of Claude Flow, learning, self-learning, security, hooks, and other optimizations. Don't implement yet. Spawn swarm. That's it. Now, I've made this so it builds the way I like to build. Now, so that's your starting point. But you can change and adapt and create new and creative structures. There's a plugin system for it. So while this is doing that, let's go here, and then we're gonna do a couple things here. I'm gonna customize the system slightly better. So while that's happening, I'm gonna go here and I'm gonna do Claude dangerous skip permissions. But this time, what I'm going to do is I'm just going to customize the environment slightly. Add a DSP alias to bash RC and DSP-C. All right. And then we're going to add a -C here. Now, I could probably have done this as part of the init, but it seems like too invasive for me to go in and start doing stuff like this to your computer. So this is what I do. You could also set up dev containers that automatically do this sort of thing if you want.
And Roof, one that I already applied was at the end you can select the model, so you just minus model, and then you can.
My system, you don't need to do that. My system auto selects the model. So as agents are invoked, different models are automatically selected and chosen based on the amount of thinking, based on the amount of intelligence and whatever, and it reduces the overall request to Claude because it's self-selecting which model to associate with each agent in the swarm.
But at what level? So
at the most basic, most fundamental level of the system.
Okay,
so
that's.
You're using all models, and you can mix and match. So if you want to have different agents, one agent might use Gemini, the other agent might use the free or whatever included in the Claude code subscription, Heroku, Sonnet, or Opus 4, and it dynamically does that in real time, right? So you can, and we'll see it here in a minute. Each of these agents you see being spawned are potentially using different models, from Claude or whatever else I've made available.
And you have a EMB file to have APIs, or
yeah. So there's an MCP. So let's go to the other one, and there's a CLI. So the CLI gives you all the components. So if you do npx, you can install this as npm as well if you want as well. Flow at alpha, and we'll do hooks as an example. So this will show us all the hooks. So these are the hooks that you'll see in, and that can be invoked, for post and free and whatnot. So, and then those use helpers. So the helpers are in here. So these are different, hooks that do like pattern recognition, learning, other background agents, and they can use they're using all these hooks. There's also an MCP. So if you go in here and you do /MCP and we do Claude Flow, we can see the tools. There's a lot of them, 175 tools. Agent spawn, terminate, agent structures, memory structures, configuration, hooks, all the hooks you see before. They're all exposed through the MCP. You got attention mechanisms to learn. You've got store patterns for intelligence. So you've got everything that I was showing you earlier are all baked into the MCP server. You can use this in Antimatter. You can use this in the ChatGPT website using the MCP integration. You can anything that's capable of either seeing command line or MCP, either which, all the same stuff can interact with my system.
Rube, when you get a moment, can you take a look in the chat? I pinged you. There's a screenshot in the chat that came from the creator, I don't remember his name, Chesney or something like the creator of Claude Code Flow, and that's supposedly his flow and how he does it.
Don't know. All I know is this works really, really well. Yeah. To be honest, I'm kind of living in my own bubble. What can I say? I probably should pay more attention to what the rest of the world is doing. I don't. Okay, one thing to note, when the agents spawn, it stops. And this is really important. When you notice it's all running in background now. So that means that the system doesn't continually check the swarm and saying, are you done? Are you ready? Are you working? It actually waits, and that saves token usage. See how it's just sitting there waiting? It's waiting for the system to basically, the various agents to sort of stop and complete, right? So that saves a ton of token usage on your system. I look how many agents I've spawned, right? 10 agent swarm, and it's bacon. It's doing all its thing, and I could ask it like what's happening, but you'll see that the agent ADR 5001 is completed. It's gonna wake up, and it's going to basically say, okay, what's going on, and it'll give me a quick little update on what this agent is done and what's happening. This is spectacular. Like, so now it's giving me a real-time update. It says what's happened. Now the key features. Now I can go take a look at this. It's implemented the 4-stage learning system, retrieve, judge, distill. It's still not quite done yet. I can go to my docs. I can see the ADRs. I can start looking at these ADRs. Now the ADRs are the basis of how the system stays on point. So basically you've got, oh, well, why did you jump back up there? Let's go back down. All right, you've got this, you've got this structure, and now this keeps the system on point. Remember the ADR and the forthcoming DDDs, I'm not sure why it keeps jumping. It really wants me to see this. Cool your jets, Claudeflow. All right, so this is what's guiding the system and keeps it from drifting away from what it needs to build. There's an anti-drift capability in the system that keeps the system on point and developing against exactly what it needs to do and not going into some rabbit hole. And more importantly, not creating code that already exists. It always knows to sort of, create the system with the least amount of code possible. So now we have a DDD. All right, let's take a look at that. The domains.
Sorry to interrupt you. Is handling documentation? Because I having a problem with documentation. This
is the documentation that we will use to build the system here in a moment.
So, no, I mean the system that you implemented to control, like no drifting, security, and everything. Is it handling? Because every time I start creating things, I start having a mess of documentation.
Yeah, that's what this is.
Controlled.
It's controlled, and you don't even have to save MDs. You can do GitHub repos, whatever. And yeah, that's exactly what this is doing. So this keeps the domain model keeps it on point. It understands where and how it needs to operate. And this is the spec that it's generating to do that.
Do you have to generate the spec every single time, or is this something you could version control and boilerplate and air quotes save your tokens to boost off of?
Oh yeah, so that's a good question. Yes, you don't have to. So what the system does also, now that I've got DSP, you can export the models of the system and then import those into other environments that are similar. So tell me how I can export my Claude Flow V3 model and import it into another Claude Flow, I guess, Claude Flow environment. Now, what's cool about this is so as your system's always learning and getting better, and big projects, you can use the migration capability, which allows you to migrate your previous Claude Flow. It learns, it looks at all the memories, everything you've ever done in that project if you've used Claude Flow, and then it basically will train the new AI system based on that model, which is really useful. But you can also export your models. So what this is doing now, there are several ways to transfer your Claude Flow data between environments. There's a configuration export. You can basically export your environment as a sort of Claude Flow config. You can do your pattern transfer, and you can export your patterns to an IPFS store, registry.
Like a knowledge base.
And then you can share that with anyone else who's using Claude Flow globally, and it exists on IPFS. You can export your state. So you can export all the information that learn while doing the various hooks. You can export your memories and the patterns that you use to get to that memory. And then you can do a full environmental just by basically copying this folder.
Awesome.
So you can basically combine multiple locations. Taking it a step further, I will be releasing this, I don't know, in a week or so. You can connect this to the ReuVector Postgre database and have multiple independent environments all somewhat connected and sharing learnings on a sort of macro level. So if I have 100 different repos that I'm working with, and there's certain things I want them to learn about how I like to build stuff broadly, I can share that within the structure of my Postgre, but I can then replace all the local learning systems rather than using SQLite and my vector system. You can just use it as a kind of central kind of knowledge system, and then it learns within the Root Vector Postgre database based on all of the different systems that are running, and as a collective intelligence using the HiveMind capability as well. It's crazy.
Thank you. Thank you for this.
How does it reconcile conflicting memories or patterns?
I've got a multi-level. Well, there's several ways I do it. There's a multi-level compression, tensor compression, I think they call it, that allows for short-term and midterm and longer-term memories. And the longer the information resides, the less detail I keep from that. I keep the most important parts of it based on the attention mechanism, GNN and whatnot, that says, here's what you really need to know. And I get a 96% sort of compression of long-term memory. So I'm not generating massive amounts of data, but the stuff that's new and doing right now is basically uncompressed. And it gives you all the information it needs. And over a series of time, over hours or days or weeks, it compresses that information automatically. But I don't lose any of the understanding because I've mapped the attention mechanisms, the neural structures, the language models, and all the things that guide the system to understand the most important parts of the system. Then I allow the system to make its own determination on what is truly meaningful based on the context of all that information that resides. It figures out that, well, Ruv's a uber nerd and he likes the hyperbolic vector blah blah blahs, and it keeps all that information for me, and that's how I make new and more interesting discoveries as I go.
So with this federated memory system, does that then mean every agent that is consuming from it has the same version of the memory but is interpreting in different ways?
Yes, that's exactly what it means. It's self-determination. So the system is self-aware. That means you can, depending on the context in which it needs to use that information, it adapts how it uses that information and what becomes meaningful based on its own requirements. So when I'm building this, system here to do, bird sound analysis, the requirements are going to be a little bit different than if I'm building a CRM for, patients or something. So the system can adapt to what it needs to know. So right now, what I'm feeding it is everything it needs to know about itself and how it needs to use the system to build this thing that I want to build, right? So what you're looking at right here is as much about how Claude Flow builds things as it is about what it needs to build, right? And at this point, at ADR 06, it's basically saying, okay, we've got a good structure for how we want to secure and do various things. Now we need to implement the thing. And this is how we're going to handle the sort of recording and the sensor and the clustering and the learning, right? And I could probably read through this more closely. Oops, my system is acting funny here. All right, and so it's lots of detail here. Then we can look at the API design. The API design is always a good place to start. Now, last thing I'm going to do, I think we're almost done, ready to spawn the actual swarm. And we're going to take, we're done. Okay, perfect. Nope, we're not done. Wrong one. We're almost done.
Ruv, I've got a question around some of the things you've done at the moment. Was it fair to put this like, the old way we do stuff like in a spike? That's kind of what you've been kind of building out, helping that because the Claude starts, without much knowledge of what the user wants to do. And what it appears like to me that you've been doing is more like a research spike where you now kind of establish the boundaries and help it to then become very deterministic and avoid any kind of, unpredicted stuff. Is that fair to just kind of summarize it that way?
Well, I'm using the concepts of sparse attention, which would literally be a kind of technical implementation of what you're describing as spiking, I think. And I'm only applying attention to the particular things that need attention applied to, where traditional models are like, give me everything and then give me the most probabilistic output based on everything that you've determined, right? And that's an everything for one thing sort of approach. I'm nothing but that one thing approach, which is spiking. So I'm looking for the one neuron, the one thing, the one vector,
Exactly.
the one, and choosing that one thing and not paying attention to anything else.
Anything else? Yeah, absolutely. I'm just looking at it from a traditional way to kind of, because that's kind of like what I'm seeing. Even though like we, we're more in the AI space, and some of these things are kind of, they sound different, but the more I look at it and the more I'm like, okay, wait, this is very similar to what an engineer would do with a spike. That's probably the reason why we do spikes, because we start from a position of not knowing, right? And we kind of get understand more, and then create the boundaries within which that work, what success looks like. Yeah. Thank you.
Yeah. I think that's a really good analogy. All right. So before I'm going to give you guys this, in the Vibecast GitHub repo, creating a new branch called 7 Cents. Thanks for the suggestion on 7 Cents. That was a really good one. I like that one. And we're going to, once that's, I'm going to spawn it. So all you need to do to get this thing working is basically point it at those ADRs in the DDD and tell it to basically build it. That's it. I've created the specification. The DDD will basically, utilize my DDD system here. And I'm going to remind it just to be on the safe side. So you see I have DDD domains here. This is going to tell you how far along in the development are. Here's the architecture. And I'm going to then spin up a swarm and see what the heck we can build.
So I want to understand some of your status on below. So there's only 5 DDD domains, but there's 9 ADRs. There being 9 DDD domains.
I need to update it. So let's do that right now. Update the status line. And there's drift in the spec. So you always have to interact with the status line a little bit to customize it to your particulars. So update the status line to match the DDDs we just outlined.
What does the lightning bolt status mean?
This is my attention system. I'm gonna improve that. This is basically defining the sort of a level of attention I can apply to things. I'm gonna make that more obvious in an upcoming release, and that is essentially measuring, well, the GNN within the system. You can also ask the system questions about just copy and paste it and say, what the heck does this status line do, and how can I customize it? That's basically what I'm doing. It's giving you a kind of running start to show you all the different options available to it. Update the status line to match the DD. We just create using the ADRs and available hooks and helpers. Now, just for the sake of this, I'm going to just point it at the helpers. So we're going to go here. So we have ADR compliance here. So I'm going to give it a little help and tell it that exists, but I'm also going to tell it that other things exist it could use. All right. And we're going to do that. So all these I don't have an implement. All these helpers do lots of amazing things, but you basically have to point it at that folder and kind of to say, what the heck do these helpers do? So I'm going to go back here for a sec. Tell me about the various helpers and what they do. All right, so I'm gonna pop that in here, and I'm gonna just tell it be brief. All right, we're gonna go back here. It's doing its thing. So now we're customizing this area specifically for the requirements of this particular implementation. So if there's 9 DDDs, then we should probably show 9 and so on. So that'll sort itself out here in a minute. Here we are. These are the helpers. We've got validates code against architectural decision records, which is what I'm doing right now. automated Git commits, so it can automatically commit to your Git as it does whatever it needs to do. I use that a lot. I don't use that if I'm necessarily on a public repo, but it's really useful if you're in a private environment because it just basically saves every freaking edit, and you can roll back to any minute, and at any moment. Like the common is like this worked 10 minutes ago. It can just roll back 10 minutes, and it'll just work.
Are helpers only invoked when requested, or do they get looked up and happen automatically?
Some of they can happen automatically, and some I've implemented some by default, and you can see those in the settings.json. So right here, if I can just, you'll see that I've got pre-tool matchers, post use, and you can see how I'm using those right here. So some of those are implemented. Let me find one. I'm trying to use the hooks wherever possible. I might not have implemented those. Let's see here. I'm trying to find one. Let's just find one with an SH. No, I don't have those in default. Okay, yes, I remember why I didn't do it by default. On certain machines, Bash needs to be, enabled, and execution needs to be enabled. And it gave me issues on Windows. So on Windows, you have to use some of my MJS files. So the MJS these will run on Windows. So I didn't enable by default to give it better cross platform compatibility. So in the current state, it'll work just fine on any environment. So you get lots of stuff in there. What do we got here? So now it's customizing this. You can see it's customizing the status line script. And I've given you 2 status lines, by the way. You've got a status line MGS if you're on Windows, and I do detect that, I think, automatically. And status line SH if you're on a non-Windows machine. And this I actually execute, so it should generally work. Like I was showing you in Windows earlier. All right, still doing its thing.
Are you encouraging people to run locally now? Because I've always run in code spaces for safety.
It depends. It depends. If you use a lot of code spaces, buying a Mac is cheaper. And buying, when you think about the cost of what it costs to run a code space, several code spaces all the time, just buy a Mac and do it there, and your ROI will be like a month.
Martin, use Rackspace Spot. I'm spending less than $7 a month for a combined. I think it's
no. I'm talking operational. Spot is fine if you're doing like GPU stuff, but if you're talking like a code space,
my longest running Rackspace Spot Ruve is 130 days. So yes, they call the product Spot, but I don't get interrupted.
I don't know. It's your call. Spot's a little too risky for my taste.
It is Spot in name.
Yeah, as long as you're doing frequent backups to GitHub, turn on the GitHub capability, and Spot's probably fine. It's definitely cheap.
And if you bought a Mac Mini, what sort of spec? I mean, you said M3 or M4, but you didn't say anything about memory or anything.
Oh, I maxed it out. I got all the stuff.
So when you say you max it out, how much? 64? 128?
Well, I like as much.
Oh, those only let you do 32, don't they?
You get more on M3. You can get 128 on M3.
Okay.
Yeah. So your best bet, M3 128, and you can get them way cheaper. You can basically get it refurbished or whatever. Who cares if it dies?
It's the Mac Mini, because the M3 Max MacBook Pro goes to 128.
No, the
M3 Mini.
I think it was the M3 Mini Pro. You can find it. They're the older models. It's from a couple years ago. They're not new.
And then Ruve, just to follow on that, I know I'd asked you this a couple of weeks ago. The status doesn't tend to tell you how many cores you're using, what percentage of your memory you're using. Are you keeping that somewhere so that we can set it up so it automatically leverages and creating parallel swarms to maximize the device?
Sorry. Yes, it automatically does that. Yeah, it auto does that. So now right now you're seeing a background worker here. This is checking the 7sense ADR compliance. It says it's 4% compliant, which is about right because I haven't started. The self-learning in hooks work because it's using Cloudflow. All right, now we're good. Now let's let's spawn swarm. Actually, I might need to restart this one quickly. So let's, I think DSP. All right. Oops, I gotta go a new one here. I don't know if it auto restarts, or maybe it didn't updates correctly, but we'll check there in a sec.
Are you sure it's a Mac Mini M3 and not a Mac Studio M3?
I don't know, man.
Because I'm looking at every Mac Mini M3 does not exist.
It's the Pro. I don't know. I'll get back to you. All right, so we're looking good. I don't know. I'm not. There's a problem here. I could fix it. I'm not worrying about that. You don't want to watch me debug for an hour. And I got to jump. So spawn swarm. Implement completely. Test validate benchmark. Optimize, document, continue until complete, start mission. That's it. And I got a compact. I should have probably compacted, whatever. But you can already tell that the compact is happening much less frequently. I just created a ton of different files, and I've yet to have a compact happen. So, and we've been doing this for what, 45 minutes. So you can tell that there's a significant improvement in the amount of information that. What's going on here? There we go. I'm not sure why dangerously skip permission didn't work. I probably didn't start it. I don't know. Initiating 7sense implementation, swarm initialize, spawning 10 specialized agents in parallel for full implementation. 10 makes 7, given there's a 9-step ADR, 1 coordinator and probably or tester and 9 DDD implementations.
Can you give us the info on your Mac Mini that you're proposing? Because I'm not seeing the M3.
Yeah, let me find that for you guys. I may have got the older M4. I don't know. I'll have to look that up. I'll post my actual specs for you guys. And I think the key takeaway is don't get the new one. All right, so now now we're seeing the agents spawning up. We can take a look what's happening under the covers. Swarm initialize. I need to spawn all 4 agents in parallel to work on different parts of the implementation. All right, looking good. Now the key thing we're looking for is after it's spawned it should stop. Now, Claude sometimes takes on a life of its own, but it doesn't seem to continue for me, and that's the important part. Otherwise, you're burning usage. You don't want to continually check the swarm every 2 seconds, saying, "Are you done yet? Is it good? It just needs to do its thing," and that'll save a ton on your actual usage, especially for a 10-agent swarm like what I'm in the process of launching. I'm going to quickly look at my calendar, make sure I don't have any calls at the bottom of the hour. All right.
Do you spawn the swarm in one window and then you're interrogating or launching things in the other? Is that what I'm saying?
Exactly. That's exactly what you're doing.
Got it.
So,
thank you.
Yeah, so you could all these work in unison. So I can go into another one and say what's happening with the swarm, or how can I help? Or I can just sit back and let it do its thing for a while, which is probably what I'm going to do right here. I don't think I need to do any introspection. Now, I could also just ask it here. All right, so now it's stopped. That means it worked. So the 7sense implementation swarm launched. We got the coder. It's working. We got the coder 2 doing the Sense7 audio. We got the Sense7 embedding. We've got a sense vector system. We've got the learning system. And this is what it's building. Like, this is me pushing this thing to the absolute limit. This research literally just came out this morning. It's state of the art, sort of basically being able to use animals and nature and whatnot as a sensor system that I can train the system on. I literally can, if I'm doing this right, and I'm going to go out into left field here for a moment. So whatever. I can use this to sense things like potential earthquakes. I can use this to sense environmental changes, potentially correlating things like weather and other things that maybe we have a hard time picking up on, but animals might sense better than we do. And then training the system to listen and understand those things and create real-time learning patterns based on those things that are happening, using a novel form of self-learning AI and an embedding system that acts as a translation engine that understands essentially how a bird communicates, and then automatically handles the structure to save that in a hyperbolic environment, so it understands how to then communicate, coordinate, decipher that network. That's what it's building. So if I can, and I'm pretty confident I can build anything. So I'm confident to 90-something% range that this will work just fine.
Wow.
If that would work out of the box, like right now?
This will work. 100% this will work. I'm building.
You don't have to. So you don't have to audit anything. Back and forth.
This is just, it's building. It's doing it as we can look at the code. We can see the code being generated. You know, it's still early in the process. So it's doing some research, but we'll see the SRC folder, the test folder. We see mocks being created. We got a mod, it's built in Rust. We've got the crates being created. We can see these different crates. I'm watching it build in real time.
Roof, do you ever go between Claude Web and the terminal
all the time,
back and forth on the same build? On the same build?
I could build everything you're seeing me do right now. You can go into Claude Code and basically say this. You go into Claude Code, and here's what you do. So we go here, set up. So we're gonna select a repository. Let's select Vibecast. Install Claude -flow at alpha init force, and default. We'll go here and we'll. That's it. And you can do everything. You can do everything I just did.
You ever switch back and forth between terminal and the web on the same build, or you just
yes,
you start?
I do. Yeah. Okay. So for branches, I'll often go into Claude Code, and now there's the ability to switch branches. I can create new branches and then jump to that branch, get it doing its thing, and then I can push a PR and check it out in my main VS Code later. But yeah, I love using just Claude Code web. I can do my phone, chilling in front of the TV. I install this. I can vibe myself. Tonight, I want to create a subatomic nuclear reaction simulator. I don't know. Okay. I just chill and it'll go do it. Then once I've got that, I go spawn a 10 agent swarm. Remember, you can only do a maximum of 15 agents in Claude Code Web, but yeah, you can do 15 agents and it'll create all kinds of crazy stuff. So we look at it go. It's great. It's going.
Roof, sorry to interrupt. I had a question like a long time ago about when you're trying to export your model, your learner, all your patterns, your memories, and everything. It's in every single one is independent. So if I share my model will be not like a black box. It will be like anybody can audit what is inside of the model itself. I mean, I know that we're sharing something that it was learning from our projects. So when I share it, the people will be able to.
Oh, by the way, guys, Jose was your idea last week. Your idea, just straight up, that was Jose. Jose came up with the idea on last week's Vibecast to do the model export and import and the app store concept, and we implemented that week, and it's in. I should have called it the Jose model, but that was your idea. So just straight up, that wasn't me. Good, nice work on that, by the way.
Thank you. I didn't do anything. Just the idea.
You gave me the idea. Give me the idea. You gave the swarm the idea. But yeah, you fool around with it. the key here is to ask it. Just ask it.
Yeah, I
If
know.
if you have a question, or if something's not quite working, or it's not right, just ask it and say, why isn't it working? Can you fix it? That's all I'm doing.
Ruve, if we already have RuVector loaded, should we take RuVector off, just load Cloudflow V3 and have it do it, or are there benefits to keeping the RuVector if it's already there?
RuVector gives you a whole lot more. It gives you all my crazy. This is like I'd position this to be as like more digestible by people who aren't going to be intimidated by a bunch of crazy. So it's still pretty out there, but it's meant to be like, I need to build complicated things in an enterprise context. So I tried to avoid all the bells and whistles of RuVector, even though they're technically under the covers if you dig far enough. But by exposing RuVector, MPX RuVector, you give it everything it needs to know.
Okay. And if you just wanted to set something up to have a new knowledge base, would you tell it just do it on your own, or would you suggest that it also uses RuVector?
When I'm building projects, I'm using RuVector for the logic and
Okay,
structure,
that's
the
what I thought.
agents. You know, I'm using Agentic Flow for long running agents like in CodeSpace, not CodeSpaces, like Google Cloud Functions, Cloud Run, that sort of thing. Maybe using what Jed suggested on Rackspace would be a really good use case. If he's telling me they're not truly ephemeral, then that might be the best place. And I might do a Rackspace API version, because now that Jed's turned me on to it, I can't help but think about that.
It's Rackspace Spot, which is distinct from the Rackspace core product.
Yeah, the Rackspace Spot. So I think I might give, but that'd be trivial. All you guys need to do to make it work on Rackspace Spot is literally say, hey, Claude, can you deploy yourself on Rackspace Spot? Here's the API key. Right, that's it.
Ruth, about my other question was about the models that is using in every single agent that is or sub agent that is running. It will be interesting to see maybe in your display.
Yeah,
what models are getting used?
Yeah, you can do that.
That would be very interesting.
Ask Claude to do that. The status line is meant to be customized by you. Okay. The idea is, here's a bunch of stuff and here's a bunch of areas you can customize it, and I format it in a way that's nice and pretty, but it's meant for you to go and explore and customize. So hey, Claude, go customize the status line to include every time every model is included and give me a percentage of which model is being used most often. Hey, Claude, go figure out how much tokens I'm using and what savings I'm getting by using this system. Is this thing real? Is this thing actually working? Prove it. Those are the kind of questions you want to ask.
Yes.
Including my stuff. Like, it's like, this sounds too good to be true, Claude. Is this actually doing what you're promising? Like, there's no way. This is bullshit. And then it does its thing for a while, and it proves, and I can see, and I can tell it works, and that's what I'm doing.
I think the most important unlock for everyone listening is to delegate any questioning or research to Claude Code or your preferred LLM, and point it at the different repos or code sources to find the answer, and then point to you where it's referencing the answer.
Yeah,
yes,
that's exactly right. So right now you can see as the agents finish, you see it started, and this is really clean. Like, this is so much cleaner than it was before, right? You'd be like, what the hell is it doing? It's spawning, it's jumping around and fluttering and doing all kinds of crazy stuff. I've managed to stop the flittering, fluctuation stuff pretty well. Like, it happens still, especially when you're vibing, but you can tell it's much cleaner. Here's this finished. Here's what it did. This finished. Here's what it did. Right? It's so much cleaner.
The flickering generally happens if you paste in context to the input that exceeds 2x the lines of terminal that you have available. So as long as you're not pushing in too much text, you'll be fine. It's a lot easier to generate a markdown file and then point the Claude Code session to reference the file multiple ways.
Exactly. And by the way, you can drag images in here now if you want. If you take a screenshot, you can go here and, like, I can take a screenshot like this, right? So I'm gonna grab a screenshot. I can, and then I might go into a folder here. Maybe I'll create a folder called assets. And I'll paste in my screenshot. Boom. And then I'm gonna go, oh, where did I paste my screenshot? Oh, I posted it here, so I'm gonna bring in assets that wasn't in there. And now all you need to do for your asset is pop that image in there, and now you've got that image available. And for certain things, it's an image is way easier, especially when you're using UI. It's like the UI is the left-hand column isn't quite right. Take a screenshot, pop it in there, and say fix that.
That is amazing, and I think this will improve for front end development
Massively.
Yeah, massively. And is it something already implemented that it will improve the performance of front end, like making a logo, because they're open source. They're already open source projects like that.
Yeah,
when you're doing front-end development, you have to be very specific about the size of the window that you're evaluating on.
Yeah, the trick for me, I use Playwright. I have a Playwright instance that basically will do the front-end visualization and end-to-end testing, and that's generally the last step. So when I was showing you that dashboard earlier, this dashboard, let me share my screen again quick. Sorry, where is that? This dashboard, I use Playwright to get it the way I like it.
Is it an agent or a skill, or how do you use
Playwright? I tell Claude to go create me a Playwright end-to-end test and optimize kind of thing.
Playwright can be run from CLI in your respective workspaces. And there are plenty of patterns that show how to do it. The newer version is something called Vibium. It's not yet mature, but it's faster when it works.
And if it's not mature,
can you hand that out? A bunch of us would love to grab our hands on that, because Playwright's wonderful, but like you said, it's a little pokey, and it'd be great to have a faster version.
Right. So you can do some pretty cool stuff. Yeah. Anyway, I start where I begin. If I can do this.
This is awesome.
Right. It's just, here it is. It's learning. And keep in mind, this is using the WASM. This is all RuVector in browser. You can see it doing its thing. See that this is learning. You can see it learning.
Yeah. But actually what I'm thinking, Ruv, is about this image that now you can insert back. Actually, inside Antigravity, there is a browser in the same environment, and it will open, check the design, and maybe take a screenshot and paste it back and keep working on it automatically. That's what is coming to my mind right now.
Yeah,
it will be interesting.
And the other one, and this is actually quite useful. I second what you just said. Actually, I use it. The other one I was trying to do is I actually started Cloudflow within Antigravity on a terminal. And I was also working on Antigravity, but I was struggling to get Cloudflow to install in Antigravity version. So I'll retry. But I was trying to I can point sometimes the obviously terminal to Antigravity, so it gets the context. For me, I was wondering if within Antigravity, I'm in a terminal and I've got Cloud Code and Cloudflow there. I would have liked that terminal to somehow see what Antigravity has in its context. So that way I can basically, because Antigravity is free for most part of it, I'm basically able to use not just my Cloud Code allowance, but kind of put it along with Antigravity and switch between the two. So I'm just wondering if you, Ruv, or anyone may have tried that to kind of, so within in that scenario.
It works. I've used it I just don't like the UI particularly for anti-gravity, but it works just fine when I tried it. I had no issue with it. It's an MCP. Just point it at MPX Cloudflow at alpha and say add as an MCP or add it to the MCP file. If it uses the .mcp.json, then it should pick it up automatically. And it's all the capabilities are either in the hooks or in the MCP tools. Pick which one you want. The tools are going to be faster. Well, no, actually, I'm using Studio. I don't think there's any difference. It's just another interface. So yeah, they're both the same speed. NPM is going to always be faster, by the way. Not MPX is going to be slower. So if you want it fast, npm install it. You're seeing what I can do. Like, you know, I'm building anything.
I found that working with anti-gravity was a little kludgy in some ways. Like it just didn't flow as well as Cloudflow. But what I did find, there is a Gemini CLI plugin for Claude Code that you can add, and that way it can run Gemini CLI to do things that require a big context window. So if you need to look at a large code base and then kind of summarize it for Claude Code.
I've got that as well. That my model selector does that. That's exactly what it does. So you can choose the 2 million context window. There's no reason to use a 2 million context window because I've got the vector system. So if you're depending on the context window of a language model for reasoning, it's probably the wrong way to do it. But that said, you can pick and choose models for the system. So certain agents, certain tasks, whatever, can use Gemini versus using Claude Code or a local model if you prefer, for whatever purpose you want, including that one.
Would be interesting to see if if it's learning when implementing different models. So is it actually providing better results when one of the model is doing what? So it will determine which model is better for what reason.
It will. That's what the Tiny Dancer determines. It's applying attention to realize which model and which tool and which service is appropriate for whatever it needs to do, and then optimizing to not make requests to Claude, you know, specifically the API of Claude to use your usage. So if it can do something without ever making the request to Claude, it does that first. And it learns where and what it needs to do. That includes writes to files, like edits to code, whatever. And that saves a tremendous amount on your cache. I had one compress in the hour that more than an hour we've been talking. I just found, we just did the first compress. You know, on the old version, it would have done this dozens of times by this point. I've only done one in more than an hour of having this run, and it just did it just now. So that shows a substantial improvement in the amount of information that it's processing through. The fact that it took an hour plus to get the first compression. I don't know about you guys. Sometimes I get the first compression in like the first 10 minutes or 2 minutes sometimes, not an hour plus later. That alone is probably a selling point, like for something. That's just one minor feature among a multitude of features. All right, I'm done.
It'll be huge.
Yeah, I got, and we're just scratching the surface. There's so much in here. I can't even. I will need days and weeks to discover all of it. So, thanks everyone for listening to me rant for an hour and a half or 2 hours, what it's been. Yeah, it's exciting.
Yeah, short question. Where and how do you configure the extra models that are to be available, you know, like Gemini and so on?
Ask Claude.
Okay.
Ask Claude.
That's Jets. That's Jets, not you.
Ask Claude. So I know I don't want to sound patronizing, but it's true. Anything it needs to know, it already knows. Just ask it. How do I?
The problem is that very frequently, unfortunately, it bullshits, which we all know very well that they bullshit. So it's not.
It doesn't bullshit in this. Well, I could bullshit obviously, but it doesn't bullshit in the sense that I've grounded it to itself. So it knows its own capabilities. So the ability for it to bullshit is not as likely. Now, the one thing you're going to notice sometimes is the system thinks that the system is too fantastic to be a thing. And it's like, no, it doesn't do that. It's not possible. It's not using hyperbolic structures. Nobody's doing that. And then, but then I'm like, yes, it is. Look, here it is. Oh, I was wrong. So just because it says it's not possible doesn't mean it's not possible. It just means that the training it's on doesn't believe that anything has been done like this before. Therefore, this can't be doing it. But that's the biggest hurdle you're going to run into. But I've done a pretty good job of mitigating that kind of anti-pattern, whatever that is, because I've included all its core capabilities in the Claude.md file, which allows it to discover itself.
Okay, so you're saying that asking Claude Flow is substantially different than asking Claude Code Saute or ChatGPT or whatever else about the
Well,
repo.
yeah. If you ask this independent of the system, it's gonna basically say this is bullshit. No way. And like now, if you point it at my repo or get to install the npm and whatnot, then it's gonna know that it's a real thing. But
Well,
you're
sometimes
gonna
it goes the other way, because I was asking when the day before I asked you about those missing folders after installation, and I was asking ChatGPT about it, and it said, no, this is a very new design decision on the part of the author, and it wasn't. It was a bug, right? So it can go both ways. It can go.
It didn't look at the code. It was
Yeah,
it
well,
was a
no,
sec-
it
it was
did. I mean, I made it look at the repo. It was for sure looking at the repo. It's just that
yeah, we're on the
sometimes it
edge.
bullshit.
Well, no, I don't, that's not bullshit. That's like we're on this edge of something totally radically different in terms of AI structure, the vectors, the attention, the min cut, all these crazy sort of conceptual ideas that were literally theoretical a month ago. I've implemented into the system. So the system so these other systems are just not able to sort of comprehend it. And often that's back to the Wi-Fi decompose system I built a while back. That was the same problem. Everyone's like, according to ChatGPT, this is total bullshit, and therefore everyone's like, this is total bullshit. Yet the whole thing worked, right? and I was like I was the poster boy for vibe coding CTO creates a complete fictional system that it doesn't work. It actually did.
That's what brought me in. That's what brought me in, that one, and I just span it up on my Wi-Fi. I had the right Wi-Fi for it. I span it up and it just worked. I was like, fuck.
Exactly.
Exactly
My point. But how am I the poster child for like bullshit vibe coding guy? And it was like, and how was I supposed to prove it? Like, works for me was my response, right? Which is always my response. So that gets 10 million freaking views, and everyone's like, and I'm now known for being like a dummy or something. Yet, 5,000 freaking stars later, the whole thing works. But if you search for it, it's basically a case study in like how a vibe coding goes wrong. But it's actually a case study in how vibe coding goes right. Screw you, Reddit.
But it's also a case study in how a ChatGPT was giving the wrong picture of reality. So
that's more like it. Yeah.
I'm literally okay. Last comment. I showed you guys. I'm simulating reality, but on an atomic level. Like we're in a weird place right now, and the boundary between sort of what we've been doing in software and what we can do in the sort of physical world with my first steps into like chips and hardware is blurring. Now, what does my presentation look like next January, when these chips are broadly deployed in millions of devices and doing real-time learning and bird signals and finding people hidden in earthquakes? What does that world look like?
Would be the models that we share able to be loaded on your chips or not?
Yeah, I can do dynamic reprogrammable. I made the chips dynamic and reprogrammable. You can load, that WASM thing I was showing you earlier? I'm going to show you one. I got one more minute, but that lets you dynamically load WASMs and on the Silicon, as long as it's like 8 kilobytes. But yeah, you go here to WASM modules, you can load each of these on individual chips. So you can go to your chips and you can add a new chip, to define whatever it is, assign it to a cluster. And then and you can organize your clusters. Then you, I don't have any WASMs. Okay, I can go to the store. What WASMs are available? Oh, I got geothermal governor. What does that do? It provides thermal management, so it optimizes the chips to run more efficiently, kind of thing. I can create my own models. I can export those. I can download those. I can create my own templates, right in the system.
Way better than what I dreamed.
Each of those 256 cores, can have its own little agent WASM that's optimized to do that one thing, and it runs all the time trying to make the best stock trade ever. It's optimized for Polymarket to correlate between the crazy that just came out in the news versus the likelihood of that being a thing and making that trade before anyone realizes it's a thing. And that thing is running on a little device that's this freaking big. The size, look, it's the size of my watch. 256 cores, but unlike my watch, this thing will run for 5 years. Yeah, sci-fi. All right, guys, that's it. I gotta do a quick bathroom break for my next meeting.
Just as we close out, just a pointer that we have a ability to submit a little video. Rob has put up and it'll ask to be a guest on the Hackerspace. So whether that's this week or next week, and if it doesn't work for you, just email us instead. But it should work. You can just give us a little 1-minute blurb of what you want to speak about, and we're going to start using this as a feedback mechanism.
Great. All right, that was a lot of information in a very short period of time. I've been holding it all in. Yeah. All right.
Thanks a lot.
All right. See you guys tomorrow. All right.
Yeah.